So if this is the whole line, this is the start point and this is the end point, it will be very hard to find the center point. I have to find out the number of elements first. So if you do not want to go to this and count the number of elements, you can define the number of elements you want. To do that, we will see one option here. And if you are writing, just write this down. I will explain everything when we will come to that point. But right now, if you want to write this down, just write this down exactly as I explain it. So click on mesh. Once you click on mesh, the details of mesh are in this window. It says details of mesh, where you can edit the parameters. Um, okay, so if you click on if you go to details of mesh, there's an option here called as sizing. Click on this option. It will open some more options or some more parameters for you to edit. We will not be editing anything here. One thing that we will be editing is the element size. So if you click on element size, it is by default set to default. That means Ansys is free to take any element size that it deems fit. So right now we have the total length of 1000 mm. So if I want to create even number of elements here, I have to divide this with even number of elements or divide it with an even number. So let's say I give the element size here of 500. So as you can see, I have given the element size of 500 mm. Now again right click on mesh and say generate mesh. So right now you can see it has created one element of 500 mm and the second element of 500 mm. So I got the center point now or the center node now. But if I say the element size of 300, this is not actually 300. It has created 1, 2, 3, 4. So it is like 1.2. So it has not actually created 300 mm elements. And you cannot rely on this center point here. To show it even better, I will change the element size to, let's say, 350. If I change this to 350, now you can see it has created 3 elements with no center node. So this is something that you have to perform if you are not going with the 2 lines method. If you are going with the 1 line method, then you always have to change this element size to something using which the software will create a center node. So right now, if I change this to 250, I will get 4 elements. Again, generate mesh. I will get 4 elements with a node at the center. So it's up to you which method you want to follow. Now, 4 elements doesn't look so good, but it's okay. We will work with it right now. Now we will come at the point where we will have to apply the supports and the forces. First thing first, we will apply the force. But if I insert a normal force that we have used or that we have seen before, insert a force, if you look at this option here, it will always ask you for the geometry. Right now, I don't have any geometry here. By geometry, I mean vertex. I have no vertex. So if I turn on the vertex selector, this is one vertex at the left side, and this is right side vertex. There is no vertex in between. So I cannot use this option. This force option I cannot use. We have another option that you can use. So delete this force. Static structural, right click, insert. Use this option which says nodal force. This will help you apply a force on nodes. So we will use nodal force. But in Nodal Force, there is one more option or one more problem you can say. It is not asking for geometry, it is asking for named selection. So before applying this Nodal Force, we have to create a name selection. What a name selection is, I will explain it in the upcoming sessions, but how to create it is very simple. So before applying this force, let's create a named selection. So I will delete this Nodal Force. Go to this selector in the toolbar. There are three options here. First is the node selector. Second is the node, or you can say face selector. It will select the faces of elements. And third is the whole element selector. We have three options. First is the node selector. Second is the face selector, which will select the faces of elements. Third is the element selector.